Okay, for this problem, we want to solve this linear differential equation. dy dt is equal to y times 1 over 1 plus 1 over t. So notice there's an implicit 1 here as the function of t that's multiplying the y. Okay, so to get started, we use the formula for the solution of a linear differential equation. So mu of t is equal to e to the integral of 1 dt. And clearly that's going to be e to the t. Now, technically, there's a plus c, but when figuring out the integrating factor, that's not necessary because I'm going to be integrating a second time in a little bit. Okay, next we figure out the general solution. Y of t is equal to integral of 1 over 1 plus e to the t, the function on the right-hand side, times the integrating factor that we just got, dt, all divided by the integrating factor that we just got, e to the t. Okay, so we do the integral. We get integral of e to the t plus 1 over 1 plus e to the t dt divided by e to the t. And we recognize that this integral is logarithmic, that the numerator is the derivative of the denominator. So the answer is going to be natural log of 1 plus e to the t plus c. And the whole thing gets multiplied by e to the minus t. And finally, one last substitution I can make. 1 plus e to the t is always positive, and so in this case, the absolute value signs are superfluous, and so I simply get e to the minus t, natural log of 1 plus e to the t. The absolute value signs are not necessary because the thing inside the absolute value is always positive. Continuing, plus c, e to the minus t. So that is the general solution. And of course, the value of c would be determined if there was an initial condition. The problem did not ask for this, but the domain of the solution will be all real numbers. And that's we knew that ahead of time because this function 1 is defined for all real numbers. Also, this right-hand side is defined for all real numbers because the denominator cannot equal 0. And so we know ahead of time that the domain is going to be all real numbers, whatever the solution is.